Okay, in this video, we're going to talk about something called proportionality, if something is proportional or not. So what a proportion is if I have a ratio, let's say I have a cake recipe, and I have a half cup of flour for every 1 cup of sugar. Right, so those are in a ratio. So those numbers are related. And that ratio has to stay the same. The relationship has to stay the same for my cake to turn out right. Okay? So what a proportion is let's say I want to make 2 of these cakes. So if I doubled it, I would now have a cup of flour and 2 cups of sugar. So even though these ratios are different, 1/2 to 1 and 1 to 2, they're proportional because they changed by the same amount. And then these ratios are still describing the same thing, how the flour compared to sugar in a cake. Okay. And we'll get more into how do I use that, what is this for later. But for right now, we're just going to work on the process of it. So we're going to say that I can determine if 2 ratios are proportional. Okay, like I said, a proportion is just an equation stating that 2 ratios represent the same relationship. Okay. All right. So, what we would find out if I reduced these or found their unit rate is that they would be equivalent. So if I reduce them, I should get the same thing if they're describing the same relationship. So if I reduce them and the 2 ratios are equivalent, that means that they are proportional. And if they're not equivalent, I reduce them and don't get the same thing. So they're not equivalent. Then they are not proportional. Okay. So, if 2 ratios are describing the same relationship between how many teachers there are for every so many students, it should stay the same. That relationship should stay the same no matter what. Otherwise, they're describing a different situation. Okay. So, one way we can do it is by reducing the ratios. So, I would reduce both ratios. I'll grab my calculator. And if the reduced forms are equal, then they're equivalent and proportional. Okay? So, the ratio 2 to 3, I can't divide that any, but I can divide both 4 and 6 by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So 2 to 3 is the same as 2 to 3. They match. So that means that these are proportional. Okay? All right, so 10 to 24 and then 15 to 48. I see that I can divide 10 and 24 by 2. 10 divided by 2 is 5. 24 divided by 2 is 12. I can't divide 5 and 12 by the same thing. So I'm done there. Okay, so now I'm going to reduce this one. I can reduce both of these by 3. 15 divided by 3 is 5. 48 divided by 3 is 16. Those are not equal, so I draw an equal sign with a little slash through it. They're not equal, so since they're not equivalent, then they are not proportional or non-proportional. Okay, so there's that way. Sometimes reducing can be tricky. We have to go through our whole list of, what can I divide both of them by? Can I divide them by this? And then you try it and then it doesn't work. So you try something else. Sometimes that process can take a while. So here's a little shortcut, okay, the cross multiplication method. So I'm going to write each ratio as a fraction, then I'm going to cross multiply. If when I cross multiply, those things equal each other, then they are proportional. Okay. So I'm going to write 1 over 7, rid of 4. Let's erase that. This is why we don't write in pen. 1 over 7, and then I'm going to do 3 over 21. Then I'm going to cross multiply. So I'm going to multiply across diagonally. So a top and then a bottom from the fraction. So I'm going to do 1 times 21. And this step right here is really important so you can know what you're multiplying. So if you get stuck, you can come back to it and know what you did. I'm going to cross multiply the other way. 7 times 3. 1 times 21 is 21. 7 times 3 is 21. Those are equal, so these are proportional. Okay. So let's do another one. 5 to 10 and 7 to 14. I'm going to write them both as fractions. The first number goes on top of the fraction. The second number goes on the bottom. And 7 over 14. I'm going to cross multiply. So I'm going to go 5 times 14. Cross multiply the other way, 10 times 7. Okay. We can use our calculator. 5 times 14 is 70. 10 times 7 is 70. Those are equal, so since they're equal and equivalent, then they are proportional. So why is this helpful is because in life, ratios, numbers are not always related as whole numbers. You might have fractions and decimals, and you need to know how to do the same thing. So here I have a decimal. The process is still going to be the same. I'm just going to go over the cross multiplying method. Okay, so I don't know how to reduce a decimal. That's a lot to think about, and sometimes I can't do that. Okay, so I'm going to write each one as a fraction. 10 over 40 and 2.5 over 10. Then I'm going to cross multiply. And do 10 times 10. And 40 times 2.5. 10 times 10 is 100. 40 times 2.5 is also 100. Those are equal, so they are proportional. Okay. All right, 6 to 4 and 8 to 12. We're going to go 6 over 4, 8 over 12. Cross multiply, 6 times 12, 4 times 8, 6 times 12 is 72, 4 times 8 is 32. Those are not equal, so this is a non-proportional relationship. They don't describe the same thing. All right. And you can do this with fractions, okay? So it's going to look scary for a second, but then it's going to be okay, okay? So if I have fractions in my ratios, I like to start with my main fraction bars, like here. So I can make sure that they're lined up so that I can tell the difference between the top numbers and the bottom numbers. Okay, so 1/4 becomes before my colon, these two dots. So it's going to go on top of the fraction. Okay, 5 comes after the colon. It's going to go on the bottom of the fraction. Notice how I made my main fraction bars? I made them a little bit longer so I could tell. Okay, then same thing. 1/20 goes on top of the fraction. And then 1 goes on the bottom of the fraction. So we have some fractions within fractions. Looks a little scary, I know. Okay, but it's going to be okay. You got it. So I'm going to do 1/4 times 1. Cross multiply. And 5 times 1/20. Okay. 1/4 times 1 is just 1/4. If you multiply anything by 1, it stays the same. Okay. All right, and then 5 times 1/20. So I'm going to do 5 times 1/20. And it gave me a decimal, so I'm just going to change it to a fraction real quick. Is 1/4. If you use those yellow student calculators, it'll give it to you as a fraction. Mine is just a different type. Okay, all right, those are equal, so they are proportional. Okay, so last thing, flip to your practice. I'm going to do a word problem with you. I didn't realize that I forgot to put a word problem on the notes. My bad. Okay. So look at this one. So it says a recipe calls for 1/3 teaspoon of yeast for every 2 cups of flour added. Raul accidentally added 2/3 teaspoons of yeast, so then he added a total of 3 cups of flour to fix the mistake. Are the ratios of yeast to flour proportional? So I'm going to take the ratios. I have to write 2 ratios. The ratio from the recipe and the ratio that Raul used, and see if they're proportional. So it asks for yeast to flour. So from the recipe, it wanted 1/3 teaspoon of yeast, so 1/3, to 2 cups of flour. What Raul did was 2/3 teaspoons of yeast. Okay, so I'm making sure that I put yeast first on both of them and flour second on both of them. Okay, so the order does matter. You need to make sure that the labels will match. So we added 3 cups of flour. So now I'm going to write those as fractions. So I have 1/3 over 2. And then 2/3 over 3. I'm going to cross multiply. I'm going to do 1/3 times 3. And 2 times 2/3. All right, 1/3 times 3 is 1. And then 2/3 times 2 is 4/3. Those are not equal, so this is a non-proportional relationship. Proportional. Okay, so from a word problem, you're just going to find the ratios and then check to see if they're proportional or not. And that's it. You guys got this. Have fun.